Welcome. Our goal today is to help you understand in the shortest time possible the AI factory, what it is, why it's needed, why it's different from a traditional data center, and how to introduce it to your customers. Have you ever used a reasoning model as compared to a traditional LLM model? Now, these models perform long thinking to answer questions, and they're able to evaluate different strategies and decide on the best course of action. Here's an example. I have a family event, and I need to figure out the seating arrangement around a round table. Sounds simple, but there are some constraints. My in-laws don't get along with my parents. My sister needs to sit next to my little brother. My wife doesn't want to sit next to my mom. Where should each person be seated? A traditional LLM can't think through these constraints, so you get an answer that doesn't answer my original question. Now, this question consumed about 450 tokens. More on tokens in just a second. Now, if we use a reasoning model, it thinks through the requirements to arrive at a solution. But guess what? To get this quality of output requires 20 times more tokens, which is 150 times more computing power. So what exactly is a token? When you ask a model a question, it needs to be broken down into a language that the model understands, which are tokens. This process is called tokenization, and a token is a unit of text, which is about 4 characters or so. The role of the LLM is to arrange the tokens or words to produce intelligence for an organization. Now, the output from the model also generates tokens, and these are detokenized so that we can understand it. So here's why we're here today. The more tokens that need to be generated, the more compute resources that are needed. Now, back to our example, you might be thinking, given that definition, that doesn't look like 8,500 tokens. Let me show you the actual output and the step-by-step thinking the model went through, which will give you an idea of how these reasoning models tackle complex problems and solve them more accurately. So, why AI factories? One reason is the use of reasoning models. Here's another reason: agentic AI workflows, which use multiple models. More models, more demand on compute, especially if the workflow includes reasoning models. And yet another driver of AI factories: physical AI, which is much more complex, requiring even more compute resources. So why not just use the traditional data center model for token generation? Well, we know it's not going very well. Recent reports from folks like McKinsey, IDC, and Gartner, we see that 92% of organizations are investing in AI and 50% plan to use AI agents. Guess how many of these organizations have mature AI deployments? Only 1% have identified the right AI algorithms for their business and bought and scaled their infrastructure to support it. That's not a typo. The key barriers to more mature AI deployments are LLM hallucination rates and poor context of answers. Using reasoning and post-training models help to solve these issues. But as we mentioned earlier, these processes require a lot of compute resources to scale token generation, and the traditional data center is not designed to do this. This is where the AI factory comes into play. The factory takes electricity, raw data, and foundation models as inputs and generates tokens and intelligence as output. It's designed to scale and produce tokens very efficiently. So a question: how do you measure the output of a traditional data center and if it's being done efficiently? With an AI factory, tokens are not only the output, but also part of the performance and efficiency metric, like cost per token or the amount of energy it takes to produce a token over time. So what actually happens inside an AI factory to generate these tokens? At a high level, we have data preparation, where data is aggregated, cleaned, and sliced and diced. That data is then used for model training and fine-tuning. And once the model performs as expected, we move to inference, which is the process of getting a response from a model and generating tokens. These functions are what drive some of the major differences as compared to a traditional data center. For example, there's a need for accelerated infrastructure, not just CPUs, which significantly reduces the cost to produce a token, resulting in a much higher ROI for AI workloads. Another is networking. AI workloads run on distributed accelerated systems that are tightly coupled, which means you need a network fabric that provides the highest possible effective bandwidth, consistent predictable performance, and you can't have interference or noise. Now, to meet these strict requirements, there are NVIDIA Spectrum-X Ethernet and Quantum InfiniBand platforms. Now, depending on the customer's workloads, we might use ConnectX network adapters for east-west traffic and Bluefield DPUs or data processing units for north-south traffic. And with NVIDIA's AI fabric technology, it's able to constantly feed GPUs so they don't sit idle. Add in high-performance storage, and you now have the core infrastructure for an AI factory. From there, you add software to manage AI workloads and NVIDIA AI Enterprise, which is a comprehensive suite of tools, libraries, and frameworks, including NVIDIA NIM and NeMo microservices, to accelerate and simplify the development, deployment, and scaling of AI applications. To help show enterprise developers how to deliver business value with AI infrastructure, there's NVIDIA Blueprints, which are customizable AI workflow examples that include reference code, documentation, and deployment tools. There are also essential components for observability, services for installation and support, and the appropriate mechanical, electrical, and plumbing. AI factories typically require more kilowatts per rack of power and include both liquid and air-cooled systems. Now, this is not a fully custom project for our customers, which typically means higher risk of delays or overstated performance. We partner to test and validate that these systems are NVIDIA certified, which means they're tuned and optimized for optimal performance and scalability. We partner on NVIDIA Enterprise Reference Architectures, which provides AI infrastructure configuration guidance for AI factory deployments with NVIDIA certified servers, Spectrum-X networking, and AI software. Now add in services expertise, and you removed a lot of the concerns and objections around risk. Now, when you think factory, you may be thinking about a massive deployment. An AI factory can be introduced in phases, starting with a few certified systems or a single rack, and scaling up from there to tens of thousands of systems. Okay, so let's recap. AI models and workflows today can solve complex problems with reasoning, AI agents, and physical AI. They generate significantly more tokens than traditional LLMs, which are pushing the limits of what traditional data centers can support, since they are not designed for AI workloads and token generation efficiency. AI factories solve this problem. They take electricity, raw data, and foundation models as inputs and generate tokens and intelligence as outputs. They're designed to scale and produce tokens very efficiently. Tokens, as a reminder, are an excellent way to measure the capacity, throughput, and efficiency of an AI factory, especially when compared to a traditional data center. The AI infrastructure of the AI factory is composed of certified accelerated systems combined with networking and other essential components in a reference architecture, along with expert services and solutions. You now have a flexible, proven AI factory that can be aligned to support any AI workload. The AI factory provides both short and long-term opportunities because this is a strategic discussion with implications across the customer's entire organization. Here are a couple of ideas for discovery questions to use with your customers. The first is focused on how the customer plans to scale. AI reasoning can require 100 times more compute for inference than traditional AI. What are your plans for supporting this increase in compute demand? You could also ask how they quantify the value of their AI infrastructure. We measure intelligence by AI token throughput. How are you currently quantifying the business value and maximizing the performance of your AI infrastructure? These are just a few ideas. Hope this was helpful. Thank you for joining.